title of my talk is actually Terraform and Ansible in 15 minutes. Okay. I don't really have slides, so this is going to be sort of a hands-on demonstration type of talk. And hopefully, fingers crossed, they'll go okay. We'll see. So, yeah, Terraform and Ansible in 15 minutes. Sorry. Before I start, quick intro. My name is Hassy. I work for Yield.io. And I do Node.js and sort of DevOpsy things like provisioning things with Ansible and stuff like that. And so the plan for this talk is that we will create a server from nothing, from zero. We'll provision it with base packages and prepare it to run a simple Node.js application. Yeah, as I said, it's going to be very hands-on. I'm going to pull out my terminal and stuff in a second. And I should say that both Terraform and Ansible are very powerful tools which have a lot of features and are very flexible. And I will definitely not be able to tell you everything in 15 minutes, but hopefully it'll give you enough of an interest to then go off and read books and tutorials and watch screencasts and stuff, of which there are plenty. So, Terraform. What is Terraform? Terraform is science fiction. And forgive me for reading off Wikipedia here. Terraforming is sometimes, nope, not that one. Terraforming, literally earth-shaping of a planet, moon, or other body, is the theoretical process of deliberately modifying its atmosphere to make it habitable by Earth-like life. In our context, we start with nothing, we do some terraforming, and we end up with an environment that is ready to be inhabited by your application code. I can close that now. So basically, Terraform is a command line tool that wraps a bunch of cloud APIs like DigitalOcean's or AWS, EC2, CloudFront, S3, all of that good stuff. And it lets you describe your infrastructure as a bunch of configuration files. And then it lets you create actual real-world resources like AWS instances from those configuration files. So you start off with a config file and you say, for example, I want to have 10 instances on DigitalOcean of a certain type with a certain operating system with maybe certain user data supplied to those. And then you run Terraform in that configuration to make changes in the real world, i.e. spin up some DigitalOcean droplets. You can also create DNS entries and do all of that stuff. And what this means is that you can have repo, say on GitHub, which has basically text files that show you at any given moment exactly what your infrastructure looks like. And every time you change that configuration file, you run Terraform on it, and that means that the changes that your infrastructure goes through are also reflected in your source control, which is great. So that's the basics of Terraform, essentially. And I'll open up a very simple Terraform file here, if I can find it. It's not there. There it is. So this is the Terraform resource definition file. That bit at the top is my DigitalOcean access token. Please do not use it for anything because this will make changes in my DigitalOcean account. Hey. So what we're saying here is that we're declaring a resource, and resource in Terraform speak is basically any kind of logical unit of your application's infrastructure. So in this instance, it's a droplet. It could also be something like a whole Heroku application. It could be an elastic load balancer on AWS, etc., etc., etc. Terraform comes with a lot of built-in resource providers, and you can also develop your own. It's entirely open source, by the way, and it's from the guys who made Vagrant. So we say we want a resource of type DigitalOcean droplet. We give it a name, and the combination of those two has to be unique. We say we want Ubuntu 14. We give it a name which will be displayed in the web UI. Region, size of droplet, we want private networking, and this is just an ID of one of my SSH keys on DigitalOcean, which will let me access that droplet. So we write that, and then we say Terraform plan. And what this does is that Terraform goes off and it looks for all files in the current directory which end in .tf, and it loads them, and then it tells you what it will do to your infrastructure. So in this instance, let me make this bigger. Because this is the first time we will be running Terraform, there is no pre-existing state. So what we're doing here kind of looks like a diff. It says, I will add DigitalOcean droplet. These are the attributes that that droplet will have. And these things here, computed means that we'll get an IP address when we create this droplet. And we don't know it yet, but it will be. It's available to post creation script that can be part of your configuration file. So if we go off and we go Terraform apply, it will actually go off and create this droplet for us. Hopefully. And while it's doing that, I'll talk about the configuration file a bit more, maybe. So yeah, as I said, these are just plain text files. I'm using Terraform specific configuration file format there, but it also accepts JSON, which is great if you want to automatically generate infrastructure definitions. It's all declarative. If you have more than one .tf file in current directory, then Terraform will load all of them and append them all to each other instead of merging. And it's safe to do that because they're declarative, so things will not overwrite each other. Let's see what's happening here. Okay, this should be taken as long as it's taken. And yeah, the syntax is very flexible, very powerful, very rich. You can do all sorts of things like comments, multi-line strings. You can do templating. All of this good stuff. I'm not really going to talk about that because I don't have time for it. So, okay, great. So it tells us that a droplet has been created. So if I go into my DigitalOcean account, there it is. Boom. And say if we didn't want that droplet anymore, what we could do is this. So if we comment out this definition, and then do Terraform plan. So Terraform created a state file after it ran that command. So this file, I'll just do ls on it. It's a JSON file that describes the current state of your infrastructure as it is in the cloud. And you would check this into your source control, and you really want to keep this safe because Terraform depends on this file being present for any subsequent what do you call it? If I just do Terraform plan here now, so it does a diff, and then it tells us that based on the state file that we have, it would remove this droplet. We're not actually, so if we ran Terraform apply now, it would actually go off and destroy that droplet, but we need it for the next step, so we'll keep it there. Okay, I think this is kind of it for Terraform. There's loads more. If it looks interesting, please go ahead and documentation is great. It'll tell you everything about different providers, provisioners. You can write your own plugins. do all sorts of things with it. So, with that out of the way, we can move on to Ansible. And what is Ansible? I presume that most people will be familiar with Ansible, right? Or Chef or Puppet, that sort of configuration management. Yeah, great. Okay. So anyway, Ansible.com says that Ansible is DevOps made simple, deploy apps, manage systems, crush complexity, da-da-da-da-da. That's kind of, never mind that. What Ansible really is just a DSL, a domain-specific language for that lets you configure a machine. So if in step 0 or step 1 we went from having nothing to having a droplet in the cloud, in step 2 we can use Ansible to actually do things to that machine, like install some packages. And the best way to think about Ansible is that it's more readable, easier to write, easier to maintain shell scripting. And the things that you do with Ansible are the things that you normally do from your shell, like add a user or install a package, as I said. So, close that, and we can go off. So I'm just making sure I haven't forgotten anything. Okay, so Ansible, so this folder is what your Ansible setup, I guess, would look like. We have ansible.cfg, which sets some defaults for when you run the Ansible command. In this instance, we say do not use KSA when you do things because it gets annoying really quickly, and we disable strict host key checking for convenience. But it's a really bad security practice, so maybe don't do that. And Ansible works with the main concept is Ansible is a playbook, which is a series of steps that Ansible will take. Each one of those steps being some kind of a command that it will run over an SSH connection on one of your machines. And those machines would be specified in an inventory file. So that looks like kind of like this. So for this step, we need the IP address of our droplet. There it is. In a production setting, if you're using Terraform, you'd probably have some kind of a script that would read your Terraform state definition file and then generate your Ansible inventory for you. So, yeah, basically an inventory file is a list of hosts that you have, and you can separate them into groups. So you could have a group for all of your web servers, you could have a group for all of your databases, a group for your load balancers, and then when you run a playbook, you can filter and say, only run this playbook on my web servers, for example, not on everything that I've got in my inventory. The playbook looks like this. So everything is YAML. And here we say, this playbook is basic build playbook, so this is what you do to a server that you just created to kind of set up things like monitoring IP tables, adding users, adding SSH keys, all that stuff. It says run this playbook on every host defined in the inventory file, and run it as root. And the other concept is roles. So if you have a web server, then you would split your tasks that you want to run on your web servers into a separate web server role, and a host can have more than one role. So you would probably have some kind of a common role, which would do the basic setup and installation on everything, and then you'd only run your web server role on your actual web servers. So that role definition lives under here. Main YAML. So even if you're not familiar with Ansible, it's pretty straightforward. So we install some packages first. Because it's Ubuntu, we use apt, and we say for each item defined here, make sure that it's present, and do update cache before you do the installation, so that we have the most recent versions. And we install just a couple of packages. To use an example here, then we create user Ansible, and user name Ansible, make sure the user is present. make sure the user can run sudo, add a comment, set login chain. We add an SSH key, again, pretty straightforward. And we can also copy another SSH key, which actually doesn't exist there, so I'm going to comment add for you. And the beauty of Ansible is that you can run a playbook against a single machine, or against 10 machines, or against 100 machines. And we'll do it all for you. So you'd normally have a files subdirectory there. That's where you'd put any files that you wanted to SCP over to the remote machine. You can also do templating. So, for example, if as part of your configuration you want to configure Nginx, you could put your Nginx config in there and then use Jinja templates to set values dynamically. So we'll run this playbook against our new machine now. Playbook, so we say use this inventory file, and we give it the name of the playbook. Oh. And off it goes. Oh, that doesn't look good. SSH problem. Let's see. Ah, that's the problem.
That's Veldstra root.
Yeah. Yep. Right.
I think you need to cd to that folder you're using, so it's not picking up your config file.
Which config file?
Your Ansible.ch.
You're right, yes.
Because it's doing the cowsay thing.
Yes, yeah. And yeah, I'm guessing it's rejecting unknown host there. Sweet, yes, thank you. So gathering facts step is Ansible SSHing into the machine and gathering basic information like what sort of operating system is running on that machine. So what it's going to do now is run through each one of these steps that we define here, and install packages, create users, etc., etc., etc.
There's no need for any clients on the remote.
No, unlike Chef, I think, right? And Puppet, yeah, you don't need any agents running on remote machines. Ansible is just a layer over SSH, so it makes it just a lot simpler to set up and use. So great, it's done all that. So just to make sure we can SSH into this machine. Now, can anyone? Oh yeah, there we go. Can we run Node? Yes, awesome. So this is kind of it for Terraform and Ansible. The next step would be to set up Jenkins, set up continuous integration, set up a job that would monitor your source code repository, run tests, and actually deploy your application onto this new machine. And you'd probably want to do it with Docker, and if Luke and Andy are here, they might tell you how you'd actually do that. Yeah, thanks very much.
Yes, so to answer your question, Luke and Andy are here, but we'll have Tom next.
Okay. Yeah.
Since they are still setting up something. I think they lost
Shall
something in Uber.
Shall I take questions or
Oh,
leave
yeah.
it for later? Or?
Questions. Does anyone has? Cool.
Can you hook up Terraform and Ansible together so that in Terraform you declare what playbooks to run on each host after it's bootstrapped?
Yes, you could. Terraform gives you an option to do something once a resource has been created, and then inside that handler you would have access to attributes like the IP address.
Yeah.
So yeah, you can do that. Yeah.
That would be pretty
Yeah.
cool.
What I do is I run Terraform completely as a completely separate step, and then I have a script that looks at the state file and then extracts IP addresses and then writes out an inventory file. But yeah, you could do it sort of as part of the same step.
Cool.
Yeah.
Do you have any experience with Puppet?
No.
No. Okay. I would ask you for a comparison.
Well, so Puppet is Ruby, right?
Yeah.
So I mean,
First one, I know that needs an agent, so yeah.
yeah. So yeah, first you need an agent. Second, it's Ruby. Like I guess in a way it makes it more powerful, but I like for as many things to be declarative rather than imperative because it makes life easier.
It's also DSL.
It's also
Is
a
it?
DSL as well.
Yes,
Yeah.
the
Okay.
Yeah.
DSL.
But it's like, do you have access to like raw Ruby in your?
No, actually, I think it's
That's it.
Yeah, not in Puppet.
You can also
Okay.
use Ruby, but the main method
have-
is using
Ruby.
DSL.
Okay.
yeah.
Do you have any way of monitoring the resources of the provisioning machines with the Terraform, or is it not?
So
Like memory and CPU, what are the resources of the several machines?
oh, the stuff that you provision, you want to
Yes.
know. So what you do is where is it? So when you describe a resource, you would specify the type. So so here I said, I specified that size, and then if you use DigitalOcean, that's a certain type of machine, and then what sort of CPU it's got.
Monitoring it in runtime.
Oh no, you wouldn't do that.
Monitoring.
Yeah, so as part of your Ansible script, you'd maybe install something like collect Z, which would actually collect those metrics and send them on to somewhere, and then you do monitoring that way.
Cool. Any more questions?
Yeah.
What did you say that is the main advantage of using Terraform to provision your stuff rather than just using Ansible directly? 'Cause,
Ansible doesn't do it at all.
uh,
So Terraform, you go from nothing to a machine
yeah,
available for Ansible to then provision.
but I mean Ansible also has a lot of cloud modules. Like you can spawn a machine through Ansible.
Right. I haven't used that.
Oh, okay.
Yeah.
I'm just asking because I use Ansible a lot.
Yeah.
I had Ansible, so I used the modules to create EC2 machines. I didn't know about
Right.
Terraform at all, so I just used it.
Okay. Well, I maybe need to look into.
I just want. I was just asking you. I mean, I'm sure Terraform is probably more powerful because Ansible is just the primitives. It
Right.
only has the primitives like spawn divs and stuff.
Okay.
I was just.
Yeah. No.
I thought you knew, so
No, actually,
was
no, I
asking
didn't.
for a comparison.
Yeah. No. We can maybe come up with one.
More questions? If anyone? Okay, cool. Another one from João.
What happens if you declare your topology in your state file or something, then you launch some instances, and then one of your instances dies? What happens? Yeah, you'd have to run it again.
So it hasn't happened to me, but I think Ansible can refresh. Sorry, no,
still
Ansible
on the-
Terraform.
Okay.
Yeah, it can refresh. You can refresh state, but it's a good question.
So
Actually.
it would maybe spawn another instance somewhere else.
Maybe, I don't know. I can.
Oh,
I can check
can
it
look
out.
it up later.
Yeah.
Does it periodically get information about the state of the machine, or just
No, it wouldn't. It would do it when you do Terraform plan, for example.
okay?
Yeah, Terraform is just like it's a command line tool on your computer, say. So it's not like a service somewhere that does things in the background.
More questions? Anyone? Cool. Thank you, Hassy.
Thank you.
Once more.
Thank you, guys.